Okay, so now I'm on number 6. IQ test scores are normally distributed. They have a mean of 100, standard deviation of 15, and we want to find the X score that corresponds to a Z score. So we talked about in class the formula to find X is the mean plus the Z score times the standard of deviation. In this case, our mean was 100 and our standard deviation is 15. And then we're given the Z score is 2.33. So I'm just going to rewrite this formula and plug in the pieces that we need. So X is equal to 100 plus 15 times 2.33. Oh, I wrote it backwards from that, but they're just being multiplied together. Sorry about that. And I'm just plugging it in my calculator. So I have 10 plus the 15 times 2.33. Oh, I have 100. I have to add 90 to that. And I get 134.95. So that is the X score that's associated. Now, because this is an IQ test score, normally they're whole numbers. So a better expression would be just to round it off to 135. All right, assume the heights of men are normally distributed with a mean of 69.4, standard deviation of 1.3. If the top 5% and the bottom 5% are excluded from an experiment, what are the cutoff heights to be eligible? So we want to exclude this 5%, and we want to exclude this 5%. And because they're completely symmetric, when I find the Z score here, it's going to be a negative. It's going to be the exact same score here. It's just the positive of that value. So what I need is the fact that the mean is 69.4 and the standard deviation is 1.3, and I need the Z score. So I'm going to plug this in the calculator. So second function, VARS, and this time we're going to use number 3 because number 3 is the inverse norm. So second VARS, number 3. And I'm going to do the area to the left, which was 0.05. The mean was 69.4. And the standard deviation is 1.3. Now I'm going to do all these, like all your calculators are just to the left. This one, it really is to the left, but some of them they are center and right, but not everybody has this on their calculator, so I'm just going to kind of ignore the fact that I have it. And I get 67.3. So what I found was the X that's actually associated with the Z score. I could actually find the Z score and plug it all back in, but I really didn't need to know it because I needed the X value anyways. So when I think about it, I'm thinking about finding Z scores, but really I'm finding the X value. So this height associated over here is 67.3, and now I need to know what this height is. And again, I can kind of skip over finding the Z score. I can go right to the height. If this area is 0.05, then because this whole thing has to add up to 1, then the area to the left is 0.95. So this time when I plug in, I'm going to use the area of 0.95, and it's still going to be to the left. Nothing else changes in here. So second VARS, number 3. And the area where it was 0.05, I'm changing it to 0.95. And it's the same mean and standard deviation. And I get a height of 71.5. So for this experiment, they're going to not allow anyone who is shorter than 67.3 inches or taller than 71.5 inches, so that they're getting more of the average and not like the outliers that we talked about. All right, number 8, we have a tire company finds the lifespan for a brand of its tires is normally distributed with a mean of 46,800 miles. Write that. And a standard deviation of 4,000. If the manufacturer is willing to replace no more than 10% of the tires, what should the approximate number of miles for a warranty? So that 10% is all that they're willing to replace. So that's what I need to find, is the X value that goes along with the Z-score that's associated with the 10%. So second, VRS, number 3. So the area this time is 0.10. The mean is 46,800. And the standard deviation was 4,000. So I got 41,674. So they would put out their warranty that they're going to guarantee that they last at least 41,674 miles, which they probably would round it to a nicer whole number. And then they are guaranteed that they won't be replacing more than 10% of the cars, 10% of the tires out there. All right, number 9, find the Z-scores that bound the middle 74%. So I'm just going to change that percent to a decimal. So I'm writing it as 0.74. So if there's 74% in the middle, then what's left over on the sides? Well, it has to add up to be 100%. So if I do 1 minus 0.74, that gives me 0.26. So between these two pieces, it's 26%. So if I divide that by 2, then I know this is 0.13 and this is 0.13. So I need these Z-scores, and this time I am really finding the Z-scores because there's no application to it. So I need to find this and this, but these are going to be the same number. It's just this one over here is going to be negative and that one's going to be positive. So do second. Oops, sorry. VRS, number 3. The area I'm going to be doing to the left, so it's 0.13. And this is, again, is a generic case. So the mean is 0 and the standard deviation is 1. And I got a Z-score of negative 1.13. So the other score is going to be positive 1.13. If you aren't sure about that, then do the area again, but add these two together, and you can add the 0.13 plus 0.74 to get the area to the left. And that gives you 0.87. So when I plug this in, oops. And you see we get the 1.13. All right, and then the last one on here, we have for the 9th percentile, which just means the area to the left is 0.09. So this area is 0.09. So I'm doing the same thing. Second, VARS, number 3. The area is 0.09. And we get a z-score of negative 1.34. So I hope this was helpful. Stay in touch. Please stay in touch. Let me know how you're doing and if this is going to work for you or not. Occasionally I'll be posting my own videos like this, but there are other videos posted that go through the material. All right, thanks.